Hello everyone, part 6 of nucleophilic substitution reaction, that is all about MCQ problems. I have chosen these problems for different competitive exam like GATE, CSIR and JEE, but better if you watch the previous video so that you will have proper idea about nucleophilic substitution reaction, and then only you can understand all this discussion related to this solution of these problems in a better way. Okay, so let's start. Here we have the first problem. We have to choose the correct statement for the reactants A, B, and A and B, it is giving product C and D in presence of water molecule. So here water molecule is basically the nucleophile. Different options as you can see. Now molecule A or molecule B, in both cases there is presence of this OSO2 which is a good leaving group. Now if it is removed, positive charge will be generated at this position in case of A, and in case of B it will be generated at this position. Okay. Now in both cases as there is OMe group, so now this OMe group, it can attack this and there will be formation of a ring type of structure like this. Now from both A and B you will be getting a common type of ring structure, and the next step, that is a nucleophile water molecule, it can attack at this position which is in blue color C. C means if it is attacking at this position you will be getting the molecule C, okay, and that is this bond will be broken. But if you are following the red arrow, then you will be getting the product D. So both the possibilities are there, and when it is D attack, basically this bond will be broken and you will be getting this product. That means we will be getting both C and D. So which option should be correct? A and B give identical amounts of C and D. So this is the correct option. Fine. Next problem. Here 4 different solvents are given, A1, A2, A3 and A4. Dielectric constant of the solvents follow the order. That order is also given. You can see that this is the order. Among them only A and 2 capable of forming hydrogen bond. So these are the informations given about these solvents. From this we have to choose which of these solvent will be most suitable for SN1 reaction. Now for SN1 reaction we have to remember we take polar protic type of solvent. So in polar protic type of solvent, suppose this is the substrate where R is an alkyl group, X is the leaving group. So when in the first step of SN1, R plus and X minus, it is formed. Now this X minus, that is the leaving group, if the solvent is capable of forming hydrogen bond, just take the example of water molecule. Suppose several water molecules are surrounding this. So in this case what will happen? It will stabilize this X minus, that is the leaving group, and as a result this type of that is the cleavage of Rx, that will be favorable. If you want to get proper information about it, you can click on the link right now that is appearing on the screen, which is the video where I have discussed the solvent effect in case of substitution reaction. Okay. Now if that is the case, then obviously A2 and A3 we will give preference compared to the other two solvents. Now another information is also there. A2 and A3, that is fine. So we can cancel these two. Sorry, A2 and A3, that is fine. That means 4 and 1 will be cancelled, not these two. Just ignore it. So if it is the case, now among A2 and A3, which one we should choose? It should be A2 because it is having higher dielectric constant compared to A3, because higher is the dielectric constant, better will be that solvent will be better for SN1. So considering all these facts, B should be the correct option, that is solvent A2. Next problem. This problem is related to nucleophilicity and how we will decide it, that is how to know whether a good nucleophile is good or bad. For that, right now you can click on the link appearing on the screen where I have discussed the features of good nucleophile or bad nucleophile. So here what we have, if you look at the nucleophiles given, CH3CO2 minus, then water molecule CH3SO3 minus and HO minus. Now these three are basically carrying some negative charge, okay, and negatively charged species is always more nucleophilic than the neutral one. So we will keep H2 at the last position. So 2 should be at the last position, okay. Now 2 at last position means these two you can cancel. We have to choose between B and D. Now if H2 is at the last, what about the rest of the 3? Now consider this point. Concentrated or localized negatively charged species is always more nucleophilic compared to delocalized, because if it is static at a particular position, obviously it will be able to attack electron deficient carbon atom in a better way. Now HO minus, here it is localized, so 4 will be maximum nucleophilic. So 4 at maximum position, 2 at last position. This information is enough to choose the correct option, which is B. But if we want to know why 3 among 1 and 3, why 1 is better? So in case of CH3CO2 minus, here resonance is possible and you will be getting 2 resonance structure total. But if you consider this one, that is SO3 minus, here negative charge can be any of these 3 oxygen. That means resonance structure is more. So here delocalization is more. So delocalization more means obviously nucleophilicity will be lesser than 2. Okay. So sorry, not 2. This is actually number 1. I have written these 2 for resonance structure. So this will be less nucleophilic. So at first position 4, that is HO minus. After that it is 1 CH3CO2 minus, then CH3SO3 minus, and at the last position there is water molecule. Next problem. Now in this problem elimination concept is also present. So what it is saying, for the following reactions, what is the reaction? CH3, CH2, CH2, Br, Z is the nucleophile, Z minus. Now when it is substitution, this is your product. If it is elimination, this is the product, where HZ is removed and Br minus is also removed. Now Z minus, that is a nucleophile, it can be either A, CH3CH2O minus, or it can be 3CH3 substituted then O minus, that is tertiary butoxide. Okay, so 2 different types of nucleophile files are there. Now Ks and Ke, these 2 are basically the rate constant for substitution and elimination respectively. And what about U, mu? This is the ratio of rate constant substitution divided by rate constant elimination. So from this we have to choose the correct option. So here B being a bulky base, that is the second nucleophile, Me3CO minus, it will favor elimination. And how to know whether substitution or elimination is favored? For that, right now there is a link or top right corner, you can check that. So A being bulky, it will favor elimination. That means from this information we can consider this. Ke for B, obviously it will be better. Now KEB, KEA, that you can find in these 2 options, but we have to cancel any one of these 2. So for that, next what to do? So mu A is basically the ratio of Ks divided by Ke, and I have also mentioned A. And in this case, KSA, that is this factor, is greater than this one. So that is why overall mu A, this ratio, it will be greater than 1, right? But when it is the second nucleophile, that is B, now mu B is ratio of Ks by Ke, provided the nucleophile is B. So in this case, Ks for B, it is lesser than this one. That means this ratio, it is less than 1. So obviously mu A greater than 1, mu B less than 1. So what you can say? Mu A is greater than mu B, and that you can find in option 2, because we just have to choose between 2 and 3. This is the correct option. Next problem, order of the reactivity in SN1 reaction. In all cases, bromine is present as leaving group. If you consider the carbocation, because it is SN1, so we will consider carbocation. This is the carbocation from the first one, this is the carbocation from the second one, and in the last one the carbocation is like this. Now this one is basically aromatic, and how to know whether aromatic, non-aromatic or anti-aromatic, that link is right now top right corner. And this one is aromatic, this is basically anti-aromatic. I am not going into the details why it is so, because I have already said that link is there, you can check that. And what about the, as it is anti-aromatic, it will be least reactive. Okay, so it will be at last point. 2 is at last, and that you can find in which option? That you can find in C. So now you can choose option C, but what about the other two? This is minimum, this is maximum reactivity, and it will be in between because it is we cannot say it is aromatic or anti-aromatic, but here resonance is possible. Okay, so resonance is possible, and that is why we will choose the option C. There are total 6 species given, and we have to choose those compounds which can be prepared by nucleophilic substitution reaction. Compound number 1, N3 attached to aromatic ring. Now when it is so, suppose the nucleophile is there, so this type of attack, that is at this carbon, it is not very facile process. Okay, so why it is not possible? And also nucleophile attacking at this carbon, which is part of CC double bond, why these are not possible? That link is also right now top right corner. Okay, for details if you are interested. So these two attack, it is not possible. Now what about 2? Here OAC is it can be removed as it can act as a leaving group, and here reaction is possible, so I am giving a right mark. Then what about 3? Now see, this is a very hinder type of structure, and if you are forming a carbocation here, suppose you are considering SN1, because nucleophilic substitution reaction is written, it is not specifically mentioned 1 or 2, but whatever it is, you can consider both of them. So if it is SN1, carbocation cannot be planar, so as it cannot achieve planarity, so that is cancelled. And if you consider SN2, then also it is a hindered position for the nucleophile to attack. So when nucleophile will attack from the opposite side, it is really difficult, so cross. Then what about 4? Now in case of 4, it is basically example of aromatic nucleophilic substitution. Now this can happen, though I have already said that in the first molecule nucleophile cannot attack in aromatic ring which is containing leaving group, but in some special cases, if there is some electron withdrawing group, strong electron withdrawing group present, then what will happen? It will overall decrease the electron density in the aromatic ring, and as a result nucleophile will be now attracted towards this carbon which is carrying the leaving group, because overall that is electron density is less because of 2 strong NO2 group, electron withdrawing group. So this is possible. So 2 is possible, 4 is possible, 2 and 4 that you can find in third option. Okay, but why 4 is also possible? Because here OMe group is not directly attached to benzene ring, so nucleophile it can attack here and reaction is possible. Fine. So 2, 4 and 6. In which of the following cases rate is dependent upon concentration of the nucleophile? And remember, here more than one option may be correct or may not be correct, but possibility is there. So in the first case, that is number A reaction, if you consider SN1 reaction, then positive charge will be generated at this position after removal of chlorine, and this positive charge is very stable. First of all, it is 3 degree and its position is such that is it can that is resonance stabilization is possible from both phenyl ring. So that is why here SN1 is possible, and for SN1 it is not dependent on the concentration of nucleophile. That is the case you observe in SN2, not SN1. So in this case it is not dependent on concentration of nucleophile because it is SN1. And how we are deciding it? Because positive charge is very stable, and when positive charge is very stable, it will undergo SN1. Okay, so this should not be the correct option. Then though some more information is given, but I will suggest not to focus on this, because what is the optical purity of the starting material given, whether it is optically pure or not, that information is not given, so better we do not focus on this fact. Second reaction, NaI, that means nucleophile is I minus, acetone is the solvent. In this case, if you consider this equilibrium sign is there. That means when nucleophile concentration is increased, reaction will be moving towards product side because of this equilibrium sign. Another factor you can think, if there is acetone, that means it is not polar protein, it is polar aprotein. That type of solvent is good for SN2. Okay, and this information, though it is indicating SN1 because racemization, but as we do not know the initial optical purity, and also when I minus will attack here, you will be getting the same type of molecule, because nucleophile is I minus, leaving group is also I minus, right? So but problem is initial optical purity we do not know, okay, and equilibrium sign is there, acetone is there, so all this indicating SN2. So it means it should depend on the concentration of nucleophile. So this should be a correct option. Then reaction C, this is example of nucleophilic aromatic substitution because two strong electron withdrawing groups are present. Now Cl minus will be attacked by HO minus nucleophile, and in this case also, that is nucleophilic aromatic substitution, the rate determining step, in this case the nucleophile attacks, that step is rate determining. So this should also be correct option. So see some points I have mentioned here. B is reversible reaction, therefore increasing concentration of nucleophile, reaction will proceed in forward direction, so dependent on nucleophile. And C is aromatic nucleophilic substitution, SNAR, it will also depend on concentration of nucleophile, because in this case the first step is attacked by nucleophile and this step is the RDS step. So that is why nucleophile concentration matters. So this is also correct. What about the last one? The last one is, if you remove this chlorine, positive charge is here, and this is 3 degree, as well as phenyl group is there. So this is also very stable, just like first reaction. So this will also be SN1, and here this information is also matching with SN1, that is mixture of stereoisomer, both R and S. So that is why this is not dependent on nucleophile concentration. So this should be, that is B and C should be correct option. The major product of the following reaction. Here in presence of KOH and SN2, these informations are given. That means when HO minus will attack from the opposite side, this bond which is above the plane, now it will be below the plane. So if you consider this reaction, it will be like this. Now it is below the plane. But if you are directly trying to match, suppose I am giving here name P. So if you directly want to match with these options given, you will not find direct similarity, okay, because OH in the, it is not matching with any of this. Now to match this, what you can do, you have to rotate it 180 degrees. So when you are rotating it 180 degree, then it will be matching with this one. But you can also consider one simple fact. Suppose even without rotating, suppose if you are in hurry, how to choose? See here, both these groups, they are on the same side, and they are on the same side, that you can find only in the first picture, not in any of the other three. So that is also indicating that the first picture is the correct product. But if you can rotate it, it will directly give you the first one. So this is the correct option. The major product, sorry, I have mentioned elimination problem also by mistake, but whatever, let's discuss it. The major product obtained from E2 elimination of 3-bromo-2-fluoropentane, that we have to find. So 3-bromo-2-fluoropentane, first draw the structure of this molecule. So 3-bromo-2-fluoro, total number of carbon, it will be 5. This is position number 2, this is position number 3. Now this hydrogen, which is directly attached to the carbon where CF bond is present, obviously it is more acidic compared to this hydrogen, right? And among Br and F, which one is better leaving group? Obviously Br minus is better. So that is why, as this hydrogen which is more acidic, and also it is beta hydrogen with respect to bromine. This is alpha with respect to bromine, this is beta carbon, so this is beta hydrogen. So what will happen? This bond will be broken and this bond will be broken. So between 2 and 3 position there will be double bond. So between 1 and 2 position, and fluorine is still there. So it is matching with, sorry, it is matching with this option, right? CH3CH, sorry, not this one. Because if you number this, it is always better you put number, otherwise there is a high chance we will make some mistake. So it is 2, 3, and there is bond between 2 and 3. So 2 and 3 means option 4, that should be the correct option. Potassium iodide in acetone undergoes SN2 reaction with each of these 4 species P, Q, R, S. The rates of the reaction vary as. So as it is SN2, first at a first glance it seems that P should be giving, as it is 1 degree, the maximum rate. But what happens, because this is 2 degree, though this is also 1 degree, but this is very simple structure, atom of nucleophile is facile, it seems P's will be giving the maximum rate. But what happens in case of S? This molecule you can write as if it is RCOCH2Cl. So as it is CO group, it is true it is electron withdrawing, but, and if you are thinking positive charge will not be stable, but see, positive charge you don't have to consider, it is SN2, it is not SN1, right? So there is some other explanation present when CO group is present at this position. So what is the explanation? If you look at this, RCOCH2Cl I have written in this way. This is the transition state when nucleophile is attacking. So here the negative charge of the nucleophile, that is distributed between this CO, because this is the pi bond, it can be broken. So it is distributed like this. This is the transition state. So because of this delocalization of the charge on nucleophile, this is a very stable transition state. So that is why activation energy will be less and it will be giving maximum rate. So the alpha C, that is carbonyl group, accepts some of the charge of the nucleophile and it facilitates the nucleophilic attack. So that is why S will be giving maximum rate, and if S is maximum, you can easily choose option B as the correct option. So after S, next is P obviously, and after P there is R, because it is also 1 degree and it will be giving 2 degrees, so that is why it is at the last position. So S, P, R and Q, this is the correct option. Okay. So if you find it helpful, please like, share and subscribe. Thank you for listening.